medium difficulty levels for this week contest in the LeetCode about maximum bags with full capacity of rocks. So basically there are n bags that we have, and then we have two arrays, which is capacity and rocks, where the index showing that for the bag on that index, the bag ith, it has that much of capacity and currently it holds that much of rock. Now, given that we have also given additional rocks, the question is, what is the maximum number of bags that we can fill in until full capacity with those additional rocks? So for example, if we have this capacity 2, 3, 4, 5 and 1, 2, 4, 4 as the rocks for each of the bag and additional rock 2, then we can get the maximum of bag with full capacity by filling in these two rocks into the bag as 3, which is currently we know that this is already at full capacity. Then we can add 1 here, this become full capacity, and then we can also add another one either way, either here or here, right? One of it, and then we will already depleted our 2 rocks, additional rocks, and in total we can make 3 out of these 4 bags into full capacity. So that's basically the problem. Now the constraint, let's see the constraint. So n will be between 1, at least there is 1, and then to something so many, capacity at minimum 1, while rocks can be 0, meaning the bag holding no rocks yet, additional rocks at least 1. Okay, so that would be the problem actually. Now what about the solutions, the tactic for the solutions itself? Okay, essentially when we put in the additional rocks to the bag, if we think about it, it means that we can get the maximum definitely by filling in the one closest to the capacity, the max capacity, right? It means we have to convert this capacity and rocks into another array, which is the delta. The delta will show how close is the bag to the maximum capacity, and we will reach the maximum number of bags with full capacity by filling in first with our additional rocks into the bag with the smallest delta. So what happened here is we will create a delta array by doing max capacity minus rocks, and then we will sort it from the smallest to the biggest. Then we will use the additional rock to fill in one by one from the one which is actually the shortest, the smallest delta. So I have prepared the solution, which is I wrote when I'm joining the contest. Basically, first we will have the counter here, which is we going to return it back. This is basically the variable which will hold the maximum number of bags that we can have. And this is the array that I'm talking about, the delta. The delta is basically the delta between the maximum capacity and then the currently holding rocks. So what happened here is for each of the capacity, we will calculate the delta by simply doing minus here, and then we will, to make it compact, we will just consider those with the delta greater than 0, while if the delta is already 0, we just count it up to the number of bags that already in full capacity. If it is not, we will put it into our delta array. We ignore the one with the maximum because definitely it doesn't affect it at all with the additional rocks. It's already in full. Then we contribute it already to our counter. After that, we do the sorting from the smallest delta to the biggest. And then after we have all those sorting, we try to use the additional rock to fill in the delta. The additional rock will be decrement by the delta. So for each delta, we decrement it. And then if the additional rock is still greater or equal to 0, it means the delta is something that the additional rock is capable to satisfy. Then we will count it up, the number of bags that is in full capacity. After counting it up, then if ever the additional rocks goes into negative, it means the delta is already too big, and there is no more additional rock we can use to actually fill in the bag into its maximum capacity. That's why we break it early, and then we return the result. So that's basically the solution. The idea is to actually understand how is to get a maximum number of full bags, right? Which is the delta here. So the delta here is really the key points, that if you already got the idea, comes into the idea of using the delta, the rest is easier. It's basically, remember that sorting is something, a technique that usually also pretty much use a lot in solving a problem. And after that, the rest is as per se. Now, how about the time complexity analysis? The time complexity for this one is essentially, if we go through here, this is of course big O(n), where n is the number of bags. Here we just minus appending another increment, so there is nothing else. Sorting will be big O and log n. This is a generic knowledge that the best sorting algorithm in the world will be limited into the big O and log n, and the implementation in Python definitely is one of the one that reach already that maximum ceiling of any kind of sorting algorithm. And then this is the delta list. The delta list, of course, at maximum it will be big O(n), because at maximum there is nothing that is already in full, right? That will be the maximum size of delta list. And then inside this for loop is just a minus, comparison, increment, and a break. So this is, it means also at worst it will be n, but it could, the other possibility is it will be less than n because it can be break earlier. So after we got it all, because these are all different sequences, it will be a summations of the big O. Summation in big O means we take the maximum, which is in this case big O and log n. So the time complexity is big O and log n, which is held mostly by the sorting. Okay, so that's it for this problem. And actually we can try to run this to see, just to verify that it is actually within the time limits. So you can see it is accepted. Okay, so well, I knew it beforehand because this is, I submitted during the contest. And so this is it for one of this week contest problem. Thank you for watching.